Within this section, we look at the AAA architecture for management of user access to network resources. AAA defines a security architecture that is comprised of three functions referred to as authentication, authorization, and accounting. Each of these functions represents a modular component, which can be applied as components of the security framework implemented by an enterprise, and often managed through the use of client-server-based protocols such as RADIUS and HWTACACS. Implementation of the AAA architecture as a solution for enhanced functionality is introduced to reinforce the overall security framework of the enterprise network. So upon completion of this section, it is generally expected that trainees will be able to describe the schemes of the AAA security architecture, as well as successfully configure authentication and authorization schemes. As mentioned, AAA represents a framework or security architecture that is used to manage user access to a network and its resources. The term AAA itself defines the three technologies that make up this framework. This framework allows users that may or may not belong to a particular domain to access resources that are located within a given secure network. We can demonstrate through the example shown here how such services are generally supported. In this instance, we consider that a number of users that are part of the Huawei domain wish to access certain resources that exist within the shown destination network. This network is protected by a network access server that is responsible for either performing authentication and authorization of users, or supporting a AAA server that performs authentication, authorization, and also accounting of users that are permitted to access the so-called destination network. The AAA services on this server may be achieved through protocols including RADIUS and also HWTACACS. Authentication can be understood as the means by which each user validates their identity to gain permission to access certain networks and resources. Authentication within VRP is supported using one of three modes. The first of these is non-authentication, which, as the name suggests, bypasses the authentication process totally and does not provide any form of security. Local authentication is the second form of authentication that is supported and involves configuration of username and password attributes on the network access server or NAS. Since authentication is performed locally, authentication requests can be processed quickly. However, it is generally not able to support a large amount of authentication information due to limitations of device storage. We demonstrate in this example the typical authentication information that is stored within the network access server, which in this case is RDA. The final form is the use of remote authentication that again supports authentication through user information such as usernames and passwords. However, this authentication information is housed and managed within a remote authentication server, to which the network access server will consult for each authentication request. For users that are successfully authenticated, an authorization level will have been configured either in the network access server or within the AAA server that determines the permission that the individual user has in terms of the resources that the user has access to what extent those resources can be accessed, and when those resources can be accessed. In terms of authorization supported by the router, this may be limited to determining privilege levels. We demonstrate here how the implementation of an authorization server, however, is capable of managing device groups such as those represented by server A and server B, and how access to these devices can be controlled based on the user group to which a user belongs. The AAA server is also able to support the features that allow for monitoring of activity and level of usage of network resources. Through accounting, we will find that users may be monitored, for which the example we show here provides a very basic example of the type of activity logs that may be generated. Users are associated with domains in order to provide control on a per-domain basis. We are as such able to provide authentication, authorization, and accounting schemes relevant to users that are associated with a given domain. The domain itself is identified through a character, which is commonly represented by the alias character. However, other characters can also be used to distinguish the domain name from the individual username. We show here two domains in the form of the Huawei domain and the partner domain. As the authenticator, the network access server will be responsible for authenticating user access and authorizing users based on the domain to which the users belong. We will therefore find, for example, that users in the Huawei domain will have different authorization levels to those users that are considered part of the partner domain. If users are not associated with any domain, they will automatically be associated with the default domain named default. There are in fact two default domains that are supported, The other is the default admin domain, that is the default domain for users recognized as administrators. The implementation of AAA using local configuration allows for the establishment of user authentication and authorization only. In using local configuration, we are able to configure usernames and passwords for users that are to be authenticated by RTA that will operate as the network access server. We see this being performed here under the AAA view using the local user command, followed by which the username and password are defined, by which remote host devices such as host A will be authorized. To support each group of users, an authentication and authorization scheme must be created. Here we can see the authentication scheme has been named Auth1 and the authorization scheme referred to as Auth2. In both cases, authentication and authorization has been set to use a mode of local, meaning that authentication and subsequent authorization of users will be performed by the network access server, which in this case is RTA, rather than through a remote AAA server. We wish to associate in this instance the created authentication and authorization schemes with a domain called Huawei. In order to do this, the domain must firstly be created on RTA, and then the two schemes created must be associated with this domain. We see this being performed here using the domain command under the AAA view. And under the AAA domain view for this Huawei domain, we see the two schemes being bound to the Huawei domain. Following the configuration of the relevant domains and authentication and authorization schemes, we are able to use the display domain name command to view the status of the domain and the schemes which have been bound to the respective domain. We show here an example based on the Huawei domain that has been created, for which we are able to see the domain is in an active state. The authentication and authorization schemes that were created can also be seen to have been bound to this domain in the form of Auth1 and Auth2. So in summary for this section on AAA, then we just have two questions here. The first asks, which two AAA schemes are supported when configuring VRP to support the local mode? Well, VRP for ARG3 series devices will support both authentication and authorization in local mode. If accounting is required, it must be supported through remote Huawei TACACS and RADIUS-based servers. If no domain is defined for users, what action is taken? Well, users that are unable to be associated with a specific domain will be automatically associated with a domain named default.